Hello everyone. So the next question for finding the volume. Here the region is a paraboloid which is cut by a plane z equal to 2y. Okay, so below is the paraboloid and above is the plane. So let's try to focus on the sketching. Step 1. So we will take x, y and z axis as usual, and we will take a line that is z is equal to 2y in the zy plane. So this is our line z is equal to 2y. So above is the line and below is the paraboloid. So this paraboloid z equal to x square plus y square faces in the upward direction. So it will be something of this form. Okay. So our region of integration, if we see closely over here, it will be this region. All right. So we have to imagine a cylinder, an imaginary cylinder that will enclose this. So what we are going to do this time, we will take a cylinder, imaginary cylinder like this, that encloses the region. All right, so something like this on the xy plane. So we have a cylinder like this. Okay, so if we try to imagine on the xy plane, so on the xy plane, if we see, it will have a center at 1 comma 0. Okay, so we will have something like this. Why? Because on the xy plane, if we equate them, so here it will be like x square plus y square equal to 2y. That means x square plus y square plus minus 2y equal to 0. So I will complete the square. So x square plus y square minus 2y plus 1 equal to 1, or simply x square plus y minus 1 square is equal to 1. Okay, so the base is a cylinder we are considering, and this is something like this. Center is on y axis. Okay, sorry, this is 0 comma 1. Alright, so this is the base and we are imagining a cylinder on this base. This cylinder we are imagining that encloses the region, and obviously we will take the strip parallel to z axis. Alright, so this is our strip. Now the next task is to determine what will be the substitution. So for cylindrical coordinates, what we will do, put x is equal to r cos theta, y equal to r sin theta, z is equal to z, without fail the Jacobian, that is r. All right, and radius we know we have to trace this circle. So the radius is 1, so 0 less than r less than 1. Sorry, my mistake. So we have to be very cautious with the radius right now. So what will be the radius of this circle? So if we try to equate from this equation, so we are putting x, we have x square plus y square equal to 2y. So we put x is r cos theta, y is r sin theta, square is equal to 2r sin theta. So if I take r common, here it will be r square equal to r 2r sin theta, or simply the radius will be 2 sin theta. Okay, so we can see that the radius will keep varying. It will start from here, and for different theta, the value of radius will be different. All right. And this time we are going to revolve this radius. So from angle 0, it will just trace angle pi. If we see, we have to just, if this is tracing the radius, so we have to just revolve it by pi degree to cover the entire circle. Alright, so therefore our angle 0 is less than theta less than pi. Radius is from 0 less than r less than sine theta, 2 sine theta. Okay, so we can easily see here angle is 90 degree, and if I put pi by 2, I'll get 2. That is the diameter of this circle. Alright, so depending on the angle, we get a different value of radius. And for z, again I'm going to look over here, and we know that z is varying from, so on this point z is equal to x square plus y square, and if I put x is equal to r cos theta, y equal to r sin theta, this will be simply r square. and here z is 2r sine theta. Okay, so these are the range for z. Therefore, my z limit will be r square less than z less than 2r, sorry, 2r sine theta. Alright, so these are the limits which we are going to use. So theta from 0 to pi, r from 0 to 2 sine theta, z from r square to 2r sine theta. Alright, so let's do the volume now. So volume is triple integration dx dy dz, but we are doing the change of variable, so change of variable should multiply by the Jacobian. We can take this time we will take z first, because it is depending on r is depending on theta, z is also depending on theta. So therefore we are going to take 0 less than 0 less, sorry, r square less than 2r sine theta, that is dz. Then we will take dr. Okay, so dr is from 0 to 2 sine theta, and then we will take theta, that is from 0 to pi. All right, so integrating this now, so this z is a constant, so we will get 0 to pi, 0 to 2 sine theta, and r is a constant, so z from r square to 2r sine theta dr d theta. Right, so this is 0 to pi, 0 to 2 sine theta, upper limit minus lower limit, so r into 2r sine theta minus r square dr d theta. Alright, so therefore this is nothing but 0 to pi. This will be inside integration with respect to r, so sine theta is constant, so 2 sine theta I will take out, 0 to 2 sine theta r square dr minus, here it is 0 to 2 sine theta r cube dr. Alright, and that is d theta. So simplifying this further, 0 to pi, this becomes 2 sine theta r cube by 3, 0 to 2 sine theta minus r raised to 4 by 4, 0 to 2 sine theta d theta. Alright, so as we can see, this will become 0 to pi 2 by 3. This becomes sine theta into 8 sine cube theta minus this becomes 16 sine raised to 4 theta by theta d theta, sorry, by 4 d theta. So further this is 0 to pi, and this is 8 to the 16 by 3 sine raised to 4 theta minus 4 sine raised to 4 theta, right, d theta. So after taking LCM and all, so this will be 4 3s are 12, 16 minus 12 is 4. So 4 by 3 integration 0 to pi sine raised to 4 theta d theta. Alright. And it is a known fact that 0 to pi sine raised to 4 theta d theta will be 3 pi by 8. So if I substitute above, so final answer is 4 by 3 into 3 pi by 8, or simply pi by 2 is the answer. Okay, so this is a high school algebra one can easily find from any book.